As a student who attends a public high school, my peers and I were shocked to hear about the Las Vegas and Florida high school shootings. This was when I took the initiative to leverage technology to build a potential remedy for this issue. I started researching machine learning algorithms, and I came across the Chan-V's contour algorithm. This algorithm outlined shapes of blurred objects, which I thought could be an ideal method to recognize firearms based on a similar shape. Although I was successful in outlining the shape, I couldn't classify the object at hand. So, I learned about TensorFlow, an open source library for machine learning algorithms created by Google. So using pip install in Python, I downloaded TensorFlow along with thousands of images of guns for my training data. Using the commands shown in the video, I was able to input an image, such as this one, and then receive a series of numbers that represent what percent of the given object resembled a pistol, revolver, and so on. I also inputted a picture of me, and I found that TensorFlow recognized that I'm not a threat because I don't have any weapon in the picture. At university, I would be able to advance my project by detecting concealed firearms using special terahertz scanners and potentially implementing this method at schools and other buildings. Over the summer, I got a chance to intern with Gozo Cabs on facial recognition using OpenCV with Python 3 on my MacBook by installing Homebrew. I did this by creating my Python virtual environment. Additionally, I installed two libraries, dlib and facial recognition. The dlib library contains my implementation of deep metric learning, which is used to construct our face embeddings used for the actual recognition process. The face recognition, on the other hand, wraps around the dlib's facial recognition functionality, making it easier to work with. Deep learning and face recognition work using a technique called deep metric learning. For this process, instead of trying to output a single label, we're instead outputting a real valued feature vector. For the dlib facial recognition network, the output feature vector is 128D, which is used to quantify the face. So, unlike many of my friends, I don't know how to drive. But that still doesn't limit my understanding of the number of accidents caused by distracted driving. So in this summer, I turned towards programming to contribute what little I could to my community. I started off calculating the eye ratio using Euclidean geometry to determine how fatigued the driver is. If the eye aspect ratio is less than 0.2 for more than 3 seconds, an alarm goes off. The rest of the flow of the drowsiness detection algorithm is fairly straightforward. I set up a camera that monitors a stream for faces, apply facial landmark detection, extract the eye regions, and then continuously calculate the EAR. The alarm goes off whenever the driver diverts his or her eyes away from the road